Hello, everybody, and welcome to Defeat MSA's Global Symposium. I'm very happy today to have the opportunity to talk to you briefly about the Cypress program at Theravance Biopharma. My name is J.Norcliffe-Kaufmann. I'm a senior director at Theravance Biopharma, and I'm involved in the ampreloxetine program, which is we're now running a study for neurogenic orthostatic hypotension in people with multiple system atrophy. And I'm here today to tell you what you need to know. So let's start with the idea, and you've probably heard a lot about this, but MSA can, in addition to affecting movement, also affect blood pressure control. It severely impacts both motor functions, which which you will hear a lot about, producing what we call atypical Parkinsonism. But around 80% of people with multiple system atrophy in their lifetime will also have problems with the control of their cardiovascular system. And this can further impact somebody's ability to stand, walk, and move around. So let's start with what is neurogenic orthostatic hypotension and break this down. Hypertension simply means low blood pressure. Orthostatic means in the standing position or related to gravity. And neurogenic means that this low blood pressure standing is caused by a problem with the nerves. So when we break it down, that's what neurogenic orthostatic hypertension is. So what happens to the nerves in multiple system atrophy, and what causes neurogenic orthostatic hypotension? You're going to hear a lot over this symposium, or if you've not already, in the various different talks, about a protein called alpha-synuclein, which is a protein that is expressed in the end of the nerves. And what happens with alpha-synuclein, like all other proteins, is continuously folding and unfolding and folding and unfolding until it forms its structure where it has its function. But what happens in multiple system atrophy is this alpha-synuclein protein goes rogue and it misfolds. So instead of forming its usual tight shape with a function, it forms a different shape in which it's misfolded. And these misfolded proteins start clumping together and they form units and insoluble protein deposits of other misfolded proteins. And what happens is these misfolded toxic clumps start depositing in the cells of the central nervous system that support the neurons. So in effect, multiple system atrophy is caused by nerves dying off because the support cells are filled with alpha-synuclein for the most part. And this impairs the ability of the brain to control the organs. And by this, we mean organs like the bladder, as well as the heart and the blood pressure. So let's move now towards the blood pressure. And you can see in this diagram to the right-hand side that the blood pressure is controlled by what we call sympathetic nerves, which are the type of nerves that release a neurotransmitter that's known mostly release a neurotransmitter called norepinephrine. And what happens in multiple system atrophy is because these sympathetic nerves become, in a way, disconnected from the brain, they stop being able to be activated, so they lose their signaling. And as a result, you get poor control of the blood vessels. So instead of tightening up when somebody stands up, as they're supposed to do, these signals don't come through the nerves to the blood vessels, so the blood pressure falls when people stand up. So let's move now to what's the consequences of not having a nervous system that functions when you stand in the upright position. This is something that we take for granted and something that happens automatically because it's controlled by our autonomic nervous system. What I'm showing you here are signals that I recorded from a person in the laboratory that was standing up who had neurogenic orthostatic hypotension. And you can see in the gray boxes along the top, this is where we put a probe on the person's head to measure the blood flow in the brain in one of the largest vessels that is bringing really oxygenated blood to the brain, which is then distributed to allow us to remain active and conscious and control all our bodily functions. And across the bottom, you'll see that this is the blood pressure. And the blood pressure is measured with every heartbeat with a cuff on the finger. Some of you may have had this test. So you can see that when the person is lying down flat, the blood pressure is in the normal range, what we call normotensive, and the blood flow in the brain is also normal. It's on average around 50 milliseconds per centimeters per second. But you can see as the person stands up, the blood pressure falls quite steeply. So that in the upright position, the blood flow to the brain is around half. And it's when we lose about 50% of the blood flow to our brain that we start to feel symptoms like we're dizzy, lightheaded, or we feel like we might want to faint. So then you can see now when the person sits back down again, you can see that the blood pressure rises. It doesn't completely come back up to the level it was when the person was lying flat and normotensive, but you can see that the rise in blood pressure is enough to bring the blood flow in back to the brain into a normal-ish range, so the person stops feeling dizziness, lightheadedness. So this is a consequence, remember I told you, of the nerves not working properly when somebody stands up, so that blood pressure falls and blood flow to the vital organs, like the brain, follows suit. So what causes symptoms of low blood pressure, and what do they feel like? This diagram of a person is standing here, and we're going to run through the different symptoms that the person starts to experience when they stand up, if they have neurogenic orthostatic hypotension. The most often thing that people report is the sensation of dizziness and lightheadedness, which is caused by you not getting enough blood back up to the brain. People will often report also problems with vision, like dimming of vision, blackening of vision, or even tunnel vision, which is caused by not getting enough blood to the retinal nerves of the eye and the occipital cortex of the brain. This is then followed by often people reporting feelings like difficulty concentrating. It's difficult to think clearly when you don't have enough blood supply to the brain. Other symptoms of neurogenic orthostatic hypotension that occur in the standing position include this head and neck shoulder pain, which is caused by not getting enough blood to the muscles that control of the back and the neck, which gives rise to this pain or sensation that is what we call in the distribution of a coat hanger. So that often is the feeling sort of like of an achiness around the back and neck. And as blood pressure continues to fall, people start to feel the feeling of fatigue or weakness. So you can see that there are various different symptoms of neurogenic orthostatic hypotension, but they're all caused by insufficient blood supply due to low blood pressure. What is important to remember about neurogenic orthostatic hypotension is the symptoms will appear on standing. They'll often worsen with slight exercise like walking or even climbing stairs or moving around, and they will improve on sitting. But they're often very, very disabling for people and can interfere with their ability to function. What neurogenic symptoms of neurogenic orthostatic hypotension are measurable, and they're measurable in the clinic on a scale known as the Orthostatic Hypotension Symptom Assessment. And this asks people to rate all of those 6 symptoms you see in this person standing up on the left from 0 to 10, with 0 being no problems and 10 being the worst possible problems. And I want you to remember this because it's something we're going to talk about in later on in the presentation and come back to. So let's talk quickly about the management of neurogenic orthostatic hypotension in people with multiple system atrophy. You're going to hear other talks about this, but I just want to touch on this very, very briefly. It begins often with non-pharmacological or lifestyle measurements, things like taking more salt, drinking more water, or even wearing compression stockings. More often than not, the symptoms are still continue despite the person's best efforts with lifestyle measures. And people are often then started on what we call pharmacological treatment. And there are 2 drugs approved by the Food and Drug Administration for the treatment of neurogenic orthostatic hypotension. And they include droxidopa and midodrine. But these are not without problems. The first thing to remember is that each of these drugs has to be taken 3 times a day, which is particularly problemsome for many people with multiple system atrophy that have difficulty swallowing. They can also exacerbate, and indeed they carry black box warnings, is blood pressure in the lying down position, which can often be high in some people with multiple system atrophy. The other thing for us to recall is that none of these drugs are approved to work beyond 2 weeks. So we don't know whether they're beneficial long term. And around 1/3 of patients, 2/3, sorry, of patients with multiple system atrophy will remain symptomatic despite treatments with available pressor agents. So that brings us on to the investigational drug ampreloxetine, which is something that Theravance Biopharma is testing. It's designed for the treatment of neurogenic orthostatic hypotension. It's designed to be taken once daily. It's a long-acting norepinephrine reuptake inhibitor, which means that it prolongs the effect of norepinephrine. Remember, I told you that norepinephrine was that neurotransmitter that is released by the sympathetic nerves that helps tighten up the blood pressure and tighten up the blood vessels and raise blood pressure. So we're testing ampreloxetine as a potential treatment for neurogenic orthostatic hypotension with the hope that it can be beneficial in people with MSA because it can raise their blood pressure when they're standing up and help control their symptoms. So what did the previous trials of ampreloxetine tell us? Theravance Biopharma did 2 previous, what we call phase 3 back-to-back trials in people with Parkinson's disease, multiple system atrophy, and pure autonomic failure. And all of those patients can have problems with low blood pressure standing due to orthostatic hypotension. One of those studies was what we call a randomized withdrawal design. And that's something that I want to focus a little bit on now. So remember I told you about that orthostatic hypertension symptom assessment scale in which people can rate their top 6 symptoms of neurogenic orthostatic hypertension, from 10 being the worst possible to 0 being no problem at all. And you can see here, we kept people with this is data from people with multiple system atrophy, and you can see that they were on ampreloxetine on placebo for 4 weeks. But over the course of long-term treatment, you can see that their symptoms of neurogenic orthostatic hypertension started to reduce, and this is in open label, meaning they knew they were taking the drug at this point, but you can see that the symptoms came down. And what we did was we then randomized people, meaning we sort of flipped a coin whether they take placebo that you see in gray or remained on ampreloxetine treatment that you see in blue. And we wanted to see if the people that were randomized to placebo got worse and their symptoms returned back to normal at their baseline. So you can see here that continued improvement in blue of the people that remained on ampreloxetine was seen in patients with multiple system atrophy, but those that withdrew to placebo actually saw a worsening of their symptoms once they stopped taking ampreloxetine. So we use this as data to show, in fact, in the first 2 trials that we did, that ampreloxetine had a signal for being helpful for improving symptoms of neurogenic orthostatic hypotension in people with multiple system atrophy. So remember, I told you that we first started off with a blind phase with 67 people with multiple system atrophy. 64 of those people entered the open label phase where they saw the improvement in their symptoms over time. And then we saw that worsening of symptoms coming back to baseline in the people that were withdrawn to placebo, whereas those that remained randomized and stayed on ampreloxetine continued to see their symptoms be better than they were at baseline. So that was a signal for us that the drug was helpful in people with multiple system atrophy. So there's a few things to remember here. Is that the symptoms of orthostatic hypertension took several weeks to improve with the investigational drug ampreloxetine. When the investigational drug was stopped, the neurogenic orthostatic hypertension symptoms reversed back to baseline. So you might be asking, and you might be sitting there wondering, if we have this data, why do we need another phase 3 clinical trial like the Cypress study? Well, first of all, we need a trial that is specifically designed for people with multiple system atrophy. In the previous trial, it was designed for patients with Parkinson's disease, pure autonomic failure, and multiple system atrophy. But we recognize that the needs of people with MSA are similar, but there are nuances and differences. So now we need a trial that's specifically designed for people with multiple system atrophy. We also need to prove, at the moment, this is what we call an investigational drug. We show that the investigational drug ampreloxetine improves not only dizziness, lightheadedness, but all of those symptoms of neurogenic orthostatic hypotension, which can be bothersome for people with multiple system atrophy. We also need to prove that the drug is safe for people with multiple system atrophy who come with different needs and different complications compared to other diseases. And we want to show also, because neurogenic orthostatic hypotension is a chronic condition, that the drug has a beneficial effect and that effect is durable over a long period of time, which is why we need another phase 3 trial, which is ongoing. So what does the trial design look like in the Cypress study? It looks very similar to the previous trial that I showed you. It is a randomized withdrawal design where we showed people are on treatment for a period of time, and then they will withdraw either to ampreloxetine, it will withdraw to placebo or remain on ampreloxetine. In terms of candidates, we are looking for 100 people with multiple system atrophy and neurogenic orthostatic hypotension, meaning a fall in blood pressure when standing up, and symptoms with that occur when they're standing up. But critically, we're looking for people that still have the ability to stand and walk around to be able to score their symptoms. And this can be with or without assistance. People will then undergo a screening process where they visit one of the hospital centers or clinics that are involved as investigators into the trial, and they'll confirm that somebody has the diagnosis of multiple system atrophy as well as neurogenic orthostatic hypotension. After they've been approved into the trial, people will be on the investigational drug ampreloxetine for 12 weeks, and will know that they're taking the drug. And after that 12-week period, there will be 2 checkpoints in which we'll see whether people actually did report benefit in their symptoms. And if they did report benefit in their symptoms on that 10-point scale that I showed you before, they will continue into what we call the randomized phase of the trial, in which they will either withdraw to ampreloxetine or they will remain on placebo, as you see here. And that will be for 8 weeks at a time. And we're looking for 72 people with multiple system atrophy to enter into this randomized blind phase of the trial. And at the end, which is I think very, very important, is that people will be able to remain on ampreloxetine treatment if they wish to do so for an extended period of time. So you'll start on the drug, you may have a 50% chance of going to placebo, but at the end, you'll be able to go back on the drug if that's what you desire. So a couple of highlights here about the trial. After the screening period, which I mentioned, people have to go into the hospital or a clinic center to be assessed. All visits can be performed remotely in a patient's home with the investigator on typically a video link and a nurse in the home, a trained nurse. Everyone, as I mentioned, will start on ampreloxetine treatment. After 12 weeks on ampreloxetine, there'll be a 50% chance that people may withdraw to placebo. 50% of the people will remain on ampreloxetine the whole way through. And people, after completing the end of what we call the double-blind phase, this phase here, will be able to enter into the open-label phase where they'll be able to continue on ampreloxetine treatment for a long period of time if they wish to do so. So if you want more information about the ampreloxetine trial, we're very happy to provide that and discuss any questions you might have. There is an email that you can reach out to. There's a QR code here where you can visit, or you can visit the website. You can also go to clinicaltrials.gov where the clinical trial is listed, and you can find more information about where to participate and details of what's been measured in the trial, as well as call this phone number to talk to a member of the team who can direct you to one of the study sites. So I thank you very much for your time today. I hope you enjoy the rest of the talks, and I hope this was useful, and thank you very much for joining us. So goodbye.